Hi, welcome. So my name is Péter Szabó. I'm working as a Salesforce developer for 6 years now. I have been in around 20 or 30 projects through the years, and now I'm working at ingatlan.com, and I led the first Hungarian Salesforce developer course, which just have been finished the week before. And my presentation will be about trigger framework. So first of all, I would like to ask you that who is a developer? Zsolt, you are not a developer, I know you. Yeah, so not so many. Uh, and because of this, I would like to ask that who knows, who don't know what are triggers? Yeah, 2, 3, okay, 4. Yo, so let's start with some example of what triggers are. So triggers are automated processes which run for a specific object if the state of the database changes. So it can be a creation of a record, a deletion, or an update of a record. So if you create a new account, maybe a trigger will run in the background if your developers has write one. And we can write triggers for most of the objects. Standard and custom ones too. And triggers have a lot of benefits, but if we use them in a wrong way, we can have some malfunctions. So as our organization grows, the automated processes will be messier as well, especially if we have triggers in addition to declarative processes. And it can cause limit errors, unknown errors, and unexpected operation. And implementing a trigger framework can be a solution for this problem. Okay. So trigger framework supports structured, transparent, unified, and scalable ways of using triggers. When I'm talking about trigger framework, I mean it's a structured system of triggers. But I will present you some codes, so you will see what I'm really talking about. That's why we need trigger frameworks after asking the question. So it's a common mistake that we create a new trigger every time when we have to implement a new business process, which contains some modification of the state of the database. And another big mistake that we implement this logic straight in the trigger itself. So I give you an example. If I create an account, no, let's start from another perspective. So me as a developer get a request from the business side that if an account is created, I want to do this and this and this in the system. And if I don't think in structured system or don't think in a framework, I make a new trigger, like making a new class. And if a new business logic is required, I will make a new one, another one, and this will be pretty messy. And we have another question regarding this. Why is it not a good idea to store the logic in the trigger itself? Because on the first hand, this kind of implementation causes weak syntactic, and the code will be barely readable, repairable, and expandable. On the other hand, simple unit tests won't be able to test the logical steps only by creation of complex records. So these two problems are way enough to induce the implementation of trigger handler class, which contains the function logic. So what I was talking about right now, just to make it a little bit clearer, that let's go from another perspective. Who is not a developer, but who knows what are classes? Okay, that's good. That's a good way to start. So triggers are like classes, but they work in a little bit another perspective. So they run if a database change has been made, as I mentioned in the beginning. And we can implement this logic into the triggers, or we can take this logic out from the triggers and take it to a class, and the trigger will call this class, call the methods of the class to run the logic. So that was for the answer for the first question. And our second question is, why is it not a good idea to create a new trigger on a specific object every time we implement a new business logic, which I have mentioned before? It's because every new trigger increases the unstructuredness and the opacity. And we have no say on the sequence of the triggers on a specific object. Who knows that what happens if we are creating a record in the system? I mean, we have flows, workflows, process builders, validation rules, and it's a pretty long sequence, I think around 18 or 20 steps from the creation until the record will be committed to the database. And trigger just a small part of it. And if we have a lot of triggers, we have no say into their logical sequence. That's why we have to keep all of the logic in one handler class. Another problem is that SQL queries and DML statements can run several times in a transaction needlessly, causing recursion and limit exceptions. Okay, so I will give you some advantages of using a trigger framework. Most of them I have mentioned now. So the first one is outsource logic into handler classes for better transparency and testability. Okay. Second one is standardization, which induces the same operation on every trigger. In case that we have one trigger per object, we can determine the whole sequence of the process. We can prevent recursions if we want, so not in every case, but in some cases we want to prevent recursion. Most of the cases. And in case of more developers, the cooperation of developing the triggers will be easier. Okay. So the trigger framework we have implemented. I have made a research about trigger frameworks through the web, looking for a good solution which fits to the size of our organization and not too complicated. And I found a solution implemented by Chris Aldridge, and I have used it as a basis through the implementation. And we have a structure like this. So we use an interface, a dispatcher class, and the custom metadata type. The interface contains the methods which should be implemented by the handler class. The dispatcher class controls the triggers, and the custom metadata type will help us to turn on and off the triggers on a specific object. Okay, I will have some code for you. It will be interesting, mostly for the developers. So that is the interface we have used. So it has seven methods, each one for a trigger event, from before insert, before update, before delete, after insert, etc., until after undelete. And we have an isDisable method, which will help us to check if a trigger is enabled or not by the custom metadata type. And we have a trigger dispatcher class like this, which queries the custom metadata from the system, from the database, and build a map from it with the object API name and this Boolean typed checkbox if the trigger is disabled or not. And we have this run method, which have an if statement at the beginning, which checks that the handler for the specific object is disabled or not. And the switch case, or in the perspective of Salesforce, is a switch when, which goes through all of the trigger contexts and and calls the exact one which we need in our specific run. Okay, that's a little bit messy, sorry for that. But at the first 3 lines, you can see our trigger on the account. So we only have, as I mentioned, one trigger on every object, and every trigger is called the object name and the trigger. So it's called account trigger. It can be called for every trigger event, and it has only one line which calls the trigger dispatcher class. The run method I have shown you before with the switch ones, and it calls the account trigger handler class and the exact operation type. I mean the exact trigger event. The fourth line, so this one is the head of the account trigger handler, which contains the main logic. It implements the interface. As you can see, we have the methods for all of the 7 and all of the 8, but I only cut these 7 ones to this slide. So all of these 7 methods which has been declared in the interface, and some of them have some logic in it. The after delete and after undelete, they are empty, but they have to be there to be the interface implemented. And as you can see, all of the business logics are separated to different methods. And this is a class diagram. The yellow cubes shows the interface and the trigger dispatcher. We only have one from both in the system. And if there is a business need for a trigger on an object which has no triggers right now in our system, we create a trigger for it and a trigger handler, as you can see in the for the account before, and we connect it to the trigger framework. And we have this trigger settings custom metadata type, where we have a line for each object we have triggers for. And at the right side of it, we can check if the trigger is enabled or disabled for that object. And it's good because we don't have, if we want to disable a trigger for a specific object, we don't have to do anything with the code. We only can check it right here. And the way of implementation was a little bit tricky because our system is around 4 years old, and we had a lot of triggers. So first, we had to look at all the triggers and decide that a specific logic is still valid or not, because we had some logic which was unused. After that, we wrote asserted unit tests for each process to be sure about the main logic stays the same after the changes, because we made the logics to the same, but the way to get to the logic changed a lot. Then we built the framework itself and also outsourced the logic from the triggers to the handler classes connected to the framework. And in the meantime, and after the whole implementation, we ran the test classes to check if the logic stood the same, and the assertions are everything is checked green. And I really recommend for every developer to make something like this. Not only this one, there are easier ones and there are more complicated trigger frameworks on the web. But I really recommend to do this and work in a system because it saves you a lot of time. It's really easy to debug, to reuse, to scale. And thank you for listening. And if you have any questions, don't hesitate to ask. Thank you.